So in this video, we will go over how to find a solution of a higher order non-homogeneous linear differential equation with constant coefficient, also known as undetermined coefficients. So we're going to figure out how to find undetermined coefficients. So it's basically one method of solving inhomogeneous non-homogeneous differential equation. Okay, so you're used to so far you're used to saying something like this: ay prime plus by prime plus dy equals g of t. Um, the g of t is not usually zero. So first step, what I would do is first solve the homogeneous equation by setting the right side to zero. Uh, so set this to zero by solving the characteristic equation ar squared plus br plus c equals zero, and you get yh or y home. Then what step two is then find a particular solution, find yp to the inhomogeneous equation by guessing something that looks like g of t, but has generic coefficients. So yeah, we're gonna have to start guessing, and here's some rules for guessing. So if your function has a kert, the guess for yp would be ae raised to the rt. And if you have a polynomial, the guess would be at squared plus bt plus c, same degree as gt. If you have like a sine or cosine, so if you have a k sine bt or a k cosine bt, your guess would be a sine of bt plus b cosine bt. This will all make sense when we do one of the examples. If you have a little bit of combination, you do the combo, you do all these above. Then what I would do, step three, then plug in your guess along with its derivatives and solve for the undetermined coefficient. Okay, so find so to find the y home by solving the homogeneous equation, characteristic equation, your y home is equal to c1 times e raised to the rt plus c2 e to the r2t, where you have two distinct roots. If you have complex roots, your y home is c1e alpha t times cosine bt plus c2e alpha t times sine of bt. So yeah, this is all review, right? So this is if you have a complex root. If you have a repeated root, your y home is going to be c1 e to the rt plus c2 times t e to the rt. So you can only use this method for when g of t exponential, a polynomial, or a sine or cosine. Okay, and then what I would do is find yp by making a guess for the g of t. So this is kind of, we just talked about this. If you have a kert, your guess is aert, polynomial is at squared plus bt plus c. If you have a sine or cosine, or k sine bt or k cosine bt, your guess would be a sine bt plus b times cosine bt. If you have a combo, you do all of those. Disclaimer: if any term of your guess for yp looks like any term in your y home, then you must multiply your whole guess by t. So, but yeah, I'll explain that, but just go ahead and write that down. So if your yp looks like your y home, then you have to, I think you have to add a t or multiply your whole guess by t. Okay, step three, plug into your differential equation to find undetermined coefficient. Step four, find the general solution, which is y home plus yp. So let's start making guesses. We're not going to actually find the solution for it. Let's just make a guess. So on first, do a guess if possible or do steps of numbers 1 through 4. So example 1 says write down the form of a particular solution of this. This is just, where's my number one? Oh, it's because I didn't write it. Wait, so let me rewrite the guess. So let me write it down here. So let's say we had g of t, and we got to find our guess for yp. So if you have a k, if you have a constant and an e raised to the rt, the guess would be a e raised to the rt. If it's a polynomial, your guess would be at squared plus bt plus c. If you have a k sine of bt or k cosine of bt, it's going to be a sine bt plus b cosine bt. So go ahead and write this down because we're going to probably need it to write our guess. Okay, so let's try example one. Let's say we had g of t equals 5e to the 3t. So that would be this rule, right? Our g of t is a constant times e raised to the rt. So the rule states it's going to be ae raised to the rt. So the guess would be yp, and it's going to be ae. So wait, it's going to be ae rt. Okay, we're just uh, finding our yp for right now. What if we had g of t equals sin of 2t? So that is a trig, but it's this one. It would be a sine of bt or b, yeah, it would be so it would be, our guess would be yp equals to a sin of 2t plus b cosine 2t. And what if we had g of t? Okay, so this is a polynomial, so it's going to be in the form of a t squared plus bt plus c. So our guess would be, or our yp would be okay, until you get to the constant d. Okay, what if we had a little bit of combination of the two? So for example, let's say we had g of t equals t times e raised to the 2t. So we have two things. We have an exponential and we have a t, which is technically a polynomial. So, so this t is a polynomial of degree 1. And then this e to the 2t is like ce to the 2t. So when you have a combination of two things, what you're going to do is you might have to FOIL it out. So your YP is going to be, so this is a polynomial of a degree of 1. So that would be expressed as AT plus B. And then this is an exponential, so that's going to be C or A e raised to the RT or 2t. And then you're going to have to FOIL this out. So when you FOIL this out, AT times C, that's going to be ACT. ACT, and then you swap this. Okay, so when you multiply AT by CAT, that would be ACT e to the 2t plus, and then when you FOIL this out, this is going to be plus BC e to the 2t. And it looks like you can take out in e to the 2t. So I'm going to take that out. So I get A of t plus b. Okay. Let's move on to example 2. Example 2 says, write down the form of a particular solution to y prime of y prime plus pt y prime plus qt y equals g of t. And we are given g of t equals to 3e raised to the 7t times sine of 10t. So we kind of have to make a guess. We have two things. We have this 3e raised to the 7t, and then we have this sine of 10t. What do we know? Well, we know this is an exponential, so that's related to ae raised to the rt, so ae raised to the 7t. And this is a trig, so that would be expressed as, so if you have a sine or a cosine, that would be expressed as b sin of 10t plus c cosine of 10t. And what are we going to do? We got to multiply this out, right? So when you multiply this out, uh, and when you FOIL this out, you're going to get, what would we get? We're going to get A E 7t times B sin of 10t plus C A E to the 7t times cosine of 10t. Okay. Then what you would do is, so your YP, you could factor out an e to the 7t, but e to the 7t of a sin of 10t plus b cosine of 10t. Okay. What about if we had g of t is equal to 3t squared minus 9t times cosine of 2t. So what do we have? This is a polynomial, and polynomial with a degree of 2, so it would be like at squared plus bt plus c. And this is a trig, so that would be d sine of 2t plus e cosine of 2t. So anytime you have a sine or cosine, you need to have both. Right, so if you have a cosine, you're going to need a sine, and then if you have a cosine, you're going to need a sine. That's just the rule. Let me write this out. Anytime a sine or cosine, you need to have both. Okay, so when you multiply this out, it would be so this is a polynomial, and then this would be this cosine of 2t would be transferred as d sine of 2t plus e cosine e cosine 2t. So it would be expressed as this. It would be, when you FOIL it out, it would be a, because our polynomial is a power 2, so it's a constant ad t squared plus b d t plus c d. So this AD is like your A, your coefficient. This BD is like your B. This CD is like your C. Times it by sine of 2t plus A E t squared. So this is like your D, your new coefficient, and then plus B E T. This is like your E plus C E. This is like your F times it by cosine of 2t. So when you put it all together and you clean it up, you're going to get yp equals a t squared plus bt plus c plus dt squared plus et plus f times it by cosine of 2t. Okay, so this is all just a guess. Not a, it's not our solution. So let's move on to example 3. Example 3 says write down the form of a particular solution to y double prime plus pt y prime plus qt plus g of t. So we have g of t equals 6 cosine of 4t minus 5 sine of 4t plus sine of t. So what are we going to do? So we have a trig. This is a trig. This is also a trig, and this is also a trig. So let's start with this one right here. 6 cosine of 4t would be expressed as a sine of 4t plus b cosine of 4t, right? If you have a cosine, you're going to need a sine. Plus negative 5 sine Negative 5 sine of 4t is going to be plus c sine of 4t plus d cosine 4t plus, and then sine of t, this one right here, would be expressed as e sine of t plus f cosine t. So this is going to be equal to a plus c sine of 4t plus b plus d. Okay, so a plus c would be like just a number, and then b plus d is like just a number as well, like your b. Plus e sine t, so that's e sine t plus f cosine t. So this e is like your c, and then this f is like your d. So your y of p, your guess, is going to be wait, we always got to check if something looks similar, right? So does anything look similar? I think so. This a for sine t plus b cosine 4t plus c sine 4t and d cosine 4t, they're almost, yeah, they look similar. So what do we do if something looks similar? You got to multiply by a t, right? So yeah, that's important. So your yp is going to be a sine of 4t plus b cosine of 4t plus c sin of t plus d cosine of t. Let's move on. So let's say we had g of t equals 10e to the negative t plus 6t squared plus 9 minus 3 sin of 7t. So we got to make some kind of guess. Excuse me. So let's look how many terms we have. 1, 2, 3. Excuse me, 4. So let's start with the 10e to the negative et. What do we know? That is an exponential. What about 6t squared? That is, what do we know about that? That is a polynomial. What about uh, 9? What is 9? It's a constant, but it's also technically a polynomial. And then what about negative 3 sine of 17? That is a trig. What I would have done first is maybe, because we have a repeat of two polynomials, right? Maybe we can just combine them into one single polynomial. So I'm going to rewrite this problem as g of t equals to 10e to the negative at. And then I'm just going to combine these two polynomials. So it's going to be plus parentheses 6t squared plus 9, and then bring down your trig. So this is one polynomial, and then this is one sine function. and then this is 1 exponential. So your guess or your YP is going to be a e to the negative at plus our polynomial has a power of 2, so it's going to be b t squared plus c t plus d. And then our trig is like, we have a sine, so we're going to need a cosine. So it's going to be plus e sine 7t plus the coefficient f and then cosine 7t. So can you combine any of these together? I don't think so. That's all you can do. So you always got to ask yourself, can you? No. This is the most combined it can be. Okay, let's move on. Okay, let's move on to example 4. Example 4 says write down the form of a particular solution to y prime plus pt y prime plus qt y equals g of t. So let's say we had g of t equals 5e raised to the t minus 10t e to the 2t plus 3e to the 2t plus cosine of 6t. So what can we do? It looks like we have, I think we could combine some stuff, right? We have an e here, an e there, and an e there. Or actually, we can combine these two terms, the negative 10t e to the 2t and the 3e to the 2t y. Can we combine them? Because they both have e to the 2t, right? So let's rewrite this problem as g of t equals to 5e to the t plus, if you combine these, you can actually take out an e to the 2t. So this would be e to the 2t parentheses, and then you're just left with negative 10t plus 3, okay? Plus cosine of 60. Okay, now what we have is, what do we have? We have an exponential, and so exponential, exponential, and then we have a trig. So it's going to be expressed as a e t plus b e 2t, and then this is kind of like a polynomial, so it's going to be c of t plus d. And then we have a cosine of 6t, so that means we need a sine and a cosine, so it's going to be plus e sine of 6t plus f cosine of 6t. Okay. So when you kind of clean this up, you're going to get yp equals to aet plus e to the 2t times bt plus c plus d sine of 6t plus e cosine of 6t. Okay, now what we're going to do is move on. Now that we have a good understanding of finding the guess, let's actually find the general solution to the inhomogeneous differential equation. So let's do this one. So on this one, it says find the general solution to the inhomogeneous differential equation. We have y prime minus 3y prime plus 2y equals 4e raised to the 3t. So step one I would do is find yh by letting y double prime minus 3y prime plus 2y equals to 0. So that would be expressed as r squared minus 3r plus 2 equals to 0. And then you're going to solve for your r. So you could factor this out, or you could use quadratic if you like. So this would be, we're just going to factor this nicely. So with two numbers multiply 2, and now it gives you negative 3, negative 2, and negative 1. So you get r equals to 2 and r equals to 1. So my y of h is going to be c1 e to the 2t plus c2 e to the 2t. Okay, step 2, I would find yp when g of t is equal to 4e to the 3t. So what is my yp? My yp is going to be a e raised to the 3t, right? So for my gt, so my gt is on the right. This is my gt, right? And what would be my guess? My guess would be yp equals constant e raised to the 3t. So first, stop and check. This guess does not look like y of h. So open. You always got to check. Stop and check. Does not like y of h. Okay. So does a of et look like y of h? A little, right? They both have e to the. Wait, do they? No, they don't, because this is a raised to the 3t, and then this is e raised to the 2t. So they're not similar in any way. Okay, so we don't have to add an extra t. So step 3 is I'm going to plug in into differential equation. So plug into differential equation. So my yp is ae raised to the 3t. My y prime of t, my yp prime is 3a e to the 3t. My yp double prime is 9a e to the 3t. So plug it into your differential equation. So it's going to be 9. So here's our differential equation right here. Okay, so what is my y double prime? It's 9ae to the 3t minus 3 times y prime. What's my y prime? Oh, it's 3ae to 3t. Plus 2 times AE to the 3t equals to your P of t, which is 4e to the 3t. So when you kind of clean this up, this is going to be 9ae to the 3t minus 9ae to the 3t plus 2ae to the 3t equals to 4e to the 3t. What do you see that you can do? It looks like you can cancel this 9ae to 3t, right? This cancels, so now you're left with 2ae to the 3t equals to 4e to the 3t. And then just go in and solve for a. So divide this by 2, or solve for a. So get rid of this 2, and then get rid of this e to the 3t. 2 cancels, e to 3t cancels, this cancels, so you're left with a equals to 2. Step 4, put it into general solution. So it's going to be y equals to yh plus yp. So it's going to be y equals to, so your general solution is yh plus yp. So it's my yh. It is this. And then what is my yp? ae to the 3t. So when you put that all together, so your general solution is yh plus yp, so that is going to be c1 e to the 2t plus c2 e to the t plus 2e to the 3t. So this is your yh, and this is your yp. So let's move on. Okay, example 6 says find the general solution to the inhomogeneous differential equation. We have y prime minus 3y prime plus 2y plus equals to 4t squared. So the first step is find your y of h. So this now becomes r squared minus 3r plus 2 equals to 0. Go ahead and factor this out. It's going to be r, and then what two numbers multiply 2 and added gives you -3, -2, and -1. You get r equals to 2 and r equals to 1. So your y of h is going to be c1 e to the 2t plus c2 e to the 2t. I mean, c2 e raised to the t. Step 2, guess yp. So your g of t is 4t squared. So what would be our guess? Well, it's a polynomial, it's a power of 2, so your yp is going to be a t squared plus bt plus c, right? 4t squared is a polynomial with the power of 2, so that's why we go from power 2 to constant. Step 3, plug into differential equation. So your yp is going to be a t squared plus bt plus c, and then we need to find our y prime, which is 2at plus b And then we need to find our yp double prime, which is 2a. Then you plug it back into your differential equation. So plug it back into y double prime minus 3y prime plus 2y equals to 4t squared. Okay, so my y double prime is 2a minus 3y minus 3 times y prime. So that's going to be 2at plus b plus 2, and then my y is at squared plus bt plus c. And then it equals to 4t squared. So you're going to have to FOIL and clean it up. So when you do that, that would give you, so when you FOIL this out, it would be, when you FOIL it out, you're going to get 2at squared minus 6at minus 3b plus 2at squared plus 2bt plus 2c equals to 4t squared. And then try to collect like terms. So when you do try to collect like terms, you're going to get, I mean, you would get 2at squared minus 6at minus 3b plus 2at squared plus 2bt plus 2c equals to 4t squared. And then, wait, I just rewrote it. I just rewrote that as this. No, what I meant to do was collect like terms. So when you do collect like terms, it's going to be 2at squared plus. So if you collect anything with the a's, you're going to get, or anything with the power of 1. Uh, so if you collect this, and what else? This, uh, you could take out 1t, so that would be negative 6a plus 2b times t plus, uh, then if you just collect the coefficient with the power of 1, it's going to be plus 2a minus 3b plus 2c. And then that equals to 4t squared. So what we have now is somehow we're going to have to figure out your a. You're going to find your coefficient a, b, and c. So just like partial fraction decomposition, you can line up the letters. Let me write it out. So let's see. So 2at squared would equal to 4. So you're going to set it up like this. It's going to be 2a equals to 4, and then negative 6a plus 2b equals to 0. And then you have 2a minus 3b plus 2c equals 0. So over here, if you solve for a by dividing both sides by 2, you get a equals to 2. Over here, you can plug in your a values, so negative 6 times 2 plus 2b equals 0. That gives you negative 12 plus 2b. And then solve for b by adding 12. You get 2b equals to 12. Divide this by 2, you get b equals to 6. Then over here, we have our a and we have our b, so we could just plug that in. So 2 times a minus 3 times 6 plus 2c equals to 0. So it's 4. Negative 3 times 6 is negative 18 plus 2c equals to 0. 4 minus 18 is negative 14 plus 2c equals to 0. Add 14, you get 2c equals 14. Divide this by 2, you get c equals 7. So so that means your yp is going to be 2t squared plus 6t plus 7. Last step, put it in the general form. So the general form is y equals y of h plus yp. So your final solution is going to be your y of h is c1e to the 2t plus c2e to the t plus your yp we just found was 2t squared plus 6t plus 7. Okay, so this is your y of h, and this is your yp. Okay, let's do one last example. Example 7 says, find the general solution to the inhomogeneous differential equation. We have y double prime minus 3y prime plus 2y equals to 5 cosine 2t. So step 1, find your y of h. So y of h is c1e to the 2t plus c2e to the t. Step 2, find your yp by guessing. So your yp is related to your g of t, which is 5 cosine of 2t. And then step 3, plug it into your differential equation. Wait. Yeah, step 3 is plug. Wait, sorry. So your gt is 5 cosine 2t. So that means your yp, you have a cosine, so that means you're gonna need a sine. So your yp is gonna be a sine of 2t plus b cosine of 2t. Step 3, plug in into differential equation. But before you do that, always check and compare YH just to see if they're similar. If they are, you have to add extra T. So does your yp similar to your yh? Here's your yp, which is a sine of 2t plus b cosine of 2t. And then your y of h is c1e to the 2t plus c2e to the t. By the way, I skipped this step because I thought, so this is going to be r squared minus 3r plus 2. Set that to 0 and then factor. This is going to be -2, -1. Your r is 1 and your r is 2. So that's how I got this c1e to the 2t plus c2e to the 1t. So does yp resemble y of h? No, it does not. So now we can find our yp, our yp prime, and our yp double prime. So my yp is a sin 2t plus b cosine of 2t. My yp prime is 2a cosine of 2t minus 2b sine of 2t. And my yp of double prime is negative 4a sin 2t minus 4b cosine 2t. Okay, then you would plug it into your differential. Plug y double prime minus 3y prime plus 2y equals to 5 cosine of 2t. Okay, so my y double prime is negative 4a sine 2t minus 4b cosine of 2t minus 3y prime, which is 2a cosine of 2t minus 2b sine of 2t plus 2 times a, because y is 2, where y is a sine 2t plus b cosine of 2t. Ugh. And that would equal to your g of t, which is 5 cosine. Okay, so what you're going to have to do is boil it out, collect like terms. So when you FOIL out the left side, it's going to be negative 4a sine of 2t minus 4b cosine of 2t minus 6a cosine of 2t plus 6b sine of 2t plus 2a sin of 2t plus 2b cosine of 2t equals to 5 cosine of 2t. Then what you want to do is combine like terms. See, so when you do combine like terms, so it would be negative 4a plus 6b plus 2a times sine. So you could factor out a sine of 2t. So I collected the sine of 2t. So sine of 2t plus negative 4b minus 6a plus 2b cosine of 2t equals to 5 cosine of 2t. And when you simplify that even more, we simplify it as negative 2a plus 6b times sine of 2t plus negative 2b minus 6a times cosine of 2t equals to 5 cosine 2t. Okay. And then what you want to do is solve for a and your b by doing the comparison. So you can say that you can set it up as negative 2a plus 6b equals to 0. And then you have negative 2b minus 6a equals to 5. So how will we find a and b? Well, it's set up as a system of equation, right? So you can solve by elimination. So you have negative 2a plus 6b equals to 0. And then you have, careful, just line up the letters. So I'm going to put this negative 6a first, minus 2b equals to 0, not 0, 5. And then system of equation, what letter would you like to get rid of first? Let's get rid of the b. So to do so, I'm going to have to multiply the entire second equation by 3. So I'm going to rewrite equation 1. So negative 2a plus 6b equals 0. And then FOIL out this 3. So this is negative 18a. And then this is negative 6b. And then 5 times 3 is 15. The b's cancels. Negative 2a, negative 18a is negative 28. And then 0 plus 15 is 15. Solve for a, so you're going to divide this by negative 20. So you get a equals to negative 15 over 20 can be reduced by 5. So your a is going to be negative 3/4. And now we must solve for b, so you're going to substitute a back into your original equation. Let's put it in this equation. So it's negative 2 times a, which is negative 3/4, plus 6b equals 0. You clean this would be positive 6/4 plus 6b equals to 0. And then you solve for b by getting rid of the fraction by multiplying both sides by 4. So this is going to be 6 plus 24b, and then 4 times 0 is 0. Solve for b, so subtract 6, subtract 6. Divide this by 24, divide this by 24. You get b equals to negative 6 over 24, which can be reduced by 6, so that's negative 1/4. Then what we'll do is find your YP. So wait, so we found our A and our B, so our YP is going to be negative 3/4 then of 2t minus 1/4 cosine of 2t. And then step 4 would be find a general solution. Their general solution is y equals YH plus YP. So my YH is C1 e to the 2t plus c to e to the t, and then my yp is negative 3/4 sine of 2t, and then negative 1/4 cosine of 2t, right? This is your, what is this? This is your y of h, and then this is your yp. Okay, I kind of lied. We still have a few more examples. We have two more examples. Actually, one more. Yeah, this will be our last one. So example 8 says find the general solution to the inhomogeneous differential equation. We have y prime, y double prime minus 3y prime plus 2y equals 4e to the t. So first find your r, right, to find your y of h. So this is going to be r squared minus 3r plus 2 equals 0. And we can factor this out nicely. Goes r, and then what two numbers multiply? 2, and one added gives you negative 3, negative 2, and negative 1. So my r is going to be 2, and my r is going to be 1. So step 1, my y of h is going to be c1e to the 2t plus c2e 1t. Step 2, find your yp by taking a guess for g of t. So your g of t is 4e to the t, and that is an exponential, so your yp is going to be aet. Okay, then what you want to do is compare your yp with y of h. Do they even look similar? So we got to check. Yeah, this yp looks very similar to this C2ET, right? So this is not a good guess. So what you're going to have to do is add multiply it by t. So your new yp is going to be a t e to the t, right? So if your yp anything looks similar to your y of h, you're going to have to multiply your yp with t. Okay. So step 3, plug it into your differential. So let's see, your yp is a t e t. Your yp prime. How are we going to take? Well, a is a constant, so you could just take the product rule, right, and then bring down the a. So you're going to use the product rule. Your f is going to be t. Your f prime is going to be 1. Your g is going to be et. Your g prime is going to be et. So your y prime is going to be a t e t plus a e t. And then what is your y double prime or your yp double prime? Product rule again. So it's going to be a t e t. If you need to pause the video, go ahead, but I'm just applying the product rule for this again. Plus AET plus AET. And then if you kind of clean this up, This is going to be a t e t plus 2a e t. Okay, and then you're going to plug it into your differential equation. So plug it back into y double prime minus 3y prime plus 2y equals to 4. So my y double prime is a t e a t e to the t plus 2a e t minus 3. And then your y prime is going to be a t e t plus a e t plus 2 times y. So my y is just a t e t equals to uh, 4 et. Okay, boil it out. Try to collect like terms. So this is going to be a t e t plus 2a e t minus 3a t e t minus 3a e t plus 2a t e t equals to 4 et. And then you might want to collect like terms. So you can collect the ETs. Anything with the ET. So when you do that, you're going to get negative AET and then 4e to the t on the right. So they all have an ET, right? And then, yeah. So when you collect all this, you're going to get negative AET, and then solve for A. So you're going to get rid of this ET by dividing both sides by ET. So you get negative A equals to 4. And then get rid of this negative 1 by dividing both sides by negative 1. You get A equals negative 4. Now we have YP. So wait, now we know YP equals to negative 4t e to the t. And yeah. So step 4, find the general solution. Your general solution is going to be y equals y of h plus yp. So y equals y of h is c1 e to the 2t plus c2 e to the t. And then your yp is negative 4t et. So that is our last example. Okay, so I'm going to stop here.